All right. Thank you for joining us for this information session. Today, we will be discussing the part-time graduate program in Materials Science and Engineering offered at the Whiting School of Engineering at Johns Hopkins University. My name is Cheryl Williams, and I am the Recruitment and Marketing Specialist for the Whiting School of Engineering. With me is Dr. James Spicer. Jim is the chair of our part-time programs in Materials Science and Engineering. He is a professor for our full-time programs in the Department of Materials Science and Engineering and is a member of the principal professional staff at Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. His research interests include materials characterization, laser materials interactions, materials for energy, structural materials, and optoelectric and magnetic materials. Last, Jim is a graduate of our full-time programs, having earned his PhD in Material Science and Engineering from Johns Hopkins in 1991. Jim, would you like to say hello?
Yes, good evening, everybody. Thanks for joining us. And Cheryl, thank you for that lovely introduction. I appreciate it.
Thank you, Jim. For today's presentation, we'll start off with an introduction to Johns Hopkins Engineering. Next, Jim will discuss with you our part-time degree program in Materials Science and Engineering. Then we'll review some helpful information on tuition and payment options, talk about next steps and important dates, and we'll end with a live question and answer session. So why study engineering at Johns Hopkins University? Johns Hopkins University was founded in 1876 as the nation's first research university. The School of Engineering opened its doors in 1913, and in 1915 it began offering part-time engineering coursework as night classes for technical workers. Since then, we've grown to offer more than 20 master's programs that can be completed part-time. 16 of these programs can be completed entirely online. Our programs are designed by people who thoroughly understand your industry. Our faculty are all expert engineers, and our faculty and instructional designers construct new and update existing coursework every year so that it includes the most up-to-date information. In addition to our part-time programs, the Whiting School of Engineering has over 25 research centers and institutes. This includes our strong partnership with the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. We also offer full-time bachelor's, master's, and PhD programs that happen in residence at our Homewood campus in Baltimore. Our online and part-time programs are led by respected senior engineers from our Applied Physics Laboratory and faculty from our full-time programs. We are ranked in the top 25 best online graduate engineering programs by U.S. News & World Report. And of all the schools that are included in these rankings, we have the largest online part-time student population. So not only will you have lots of fellow students going through a similar learning experience, but these rankings really speak to the quality of our programs regardless of our size. And our school is experienced and well equipped to help you navigate graduate education as a part-time student. The degree that you earn studying with us part-time is of the same quality as our full-time degree programs. Your diploma will not say part-time. You are eligible and highly encouraged to participate in commencement. And as a graduate, you will be one of more than 28,000 Whiting School alumni and will join our esteemed international alumni community. So that is an overview of who we are and the value of our programs. Now Jim is going to talk to you more about materials science and engineering. Jim?
All right, thank you very much. So Cheryl's already introduced me, and these are my details. I actually work as a faculty member in the full-time program in Materials Science and Engineering, and I chair the materials program in EP. And it's a great time to be involved with the program because we have a lot of exciting things happening right now. Some of those exciting things are happening in the program's focus areas. So Cheryl, if I could have the next slide. So yeah, we have a master's degree in material science and engineering, and there's a nanotechnology concentration, which you can take additional coursework and focus your education in that area. Nanotechnology spans many different areas of science and engineering, and in materials we have some core coursework that students complete to build towards their concentration, but you can fill out the rest of your coursework by taking additional courses in other areas within EP, such as applied physics or electrical engineering or biomedical engineering. And as students are forming their program of study, if they don't want to necessarily concentrate in nanotechnology, we do have suggestions of courses they can take to focus in either biotechnology or obviously nanomaterials, which is part of nanotechnology. Again, your coursework can be in the materials program, but if you're focusing in one of these two areas, chances are you'll end up taking a lot of courses in other programs within EP. That's advantageous because many courses in the materials program are offered only in person, whereas other programs have a lot of coursework that's online, and that can help you complete your degree requirements. So for admissions, basically, we're looking for you to have a bachelor's degree in some engineering or science discipline. It's beneficial if it's somehow close to materials. It doesn't have to be in materials science and engineering, but if you have an undergraduate degree in chemistry or physics or maybe even mechanical engineering, that can lend itself to being quite successful in the program in material science. We look for a GPA of 3 or better. If you have a GPA at that level, generally you don't get put into a special category where your application is considered under special circumstances where your GPA might be lower. So we're really looking for a GPA of 3.0. We're also looking for certain prerequisite coursework in your degree program, namely calculus. Calculus 1, 2, 3, as well as linear algebra and differential equations, your general physics courses, and also general chemistry. So we look for all that basic coursework in your background. And if your degree is in some other area, but you have these basic courses and do well in them, generally that means that you could do well in material science and engineering. It's important to know also that we don't require GRE scores as part of the application process. And so you don't have to suffer through taking the GRE exam before applying. Also, I'll mention that part of your application, if your GPA isn't as strong as we would like it to be, so if you're at 2.9 or something like that, that letters of recommendation from people at your current workplace can be useful in establishing your credentials beyond your undergraduate degree program. So our degree itself, you're required to take 10 courses over a period of 5 years. And so you can see that it's relatively easy to fit in your coursework, even if you're working full time, because you might only need to take one course each semester, so 2 courses a year. In our degree program, we have 2 courses that are considered to be core courses, and every student has to take those. Those courses are structure and properties of materials, and a second course, thermodynamics and kinetics. One course is offered in the fall, the other course is offered in the spring, and currently both courses are only offered in person, so you would have to go to the site where the course is being offered and meet with the instructor directly once a week. In addition to the core classes, you would have to complete 8 elective courses, and these can be chosen from the materials program or from other programs in EP, as I've already mentioned. A nice option is a mentored research project. So if there's something at your workplace that is, let's say, research oriented, and you can find a research advisor at the Hopkins faculty who will sponsor you, generally we can figure out how to use that research project at your workplace to fulfill degree program requirements, essentially replace some of your elective courses, 1 or 2 of your elective courses with a semester-long or year-long research project. So as I've already mentioned, the 2 core classes are structure and properties of materials. That core classes offered in the fall, and second course, thermodynamics and kinetics of materials. That course is offered in the spring. So who are you guys? Who do we have in EP and material science and engineering? Well, there's a total of 32 students according to this slide, but actually I have a few more advisees than that. So, but that's a good number to stick with. Average age is 28, so young working professionals essentially, and 100% of our students are employed full-time. And you can see where our students come from. The Applied Physics Laboratory, Northrop Grumman. We actually have students who are high school teachers in the Montgomery County school system, SAFT America, government like Department of Justice, and on and on. And it really makes for a dynamic student body. And I think that's really beneficial, and why I like that some of our courses are in person, because you interact directly with other students from these other companies or institutions, and it provides a different perspective to your education, which is useful. In the online environment, you have similar interactions, but obviously it's remote, and it might not be quite as personal. So the program pathway, it's primarily on site. So as I mentioned, the core classes are definitely on site, and as you construct the degree program courses, the electives, you can choose a combination of online or in-person coursework to fulfill degree requirements. And as I mentioned already, other programs within EP have a majority of their courses online, and many of those courses are materials related. So oftentimes you can find a materials related course in mechanical engineering or applied physics that's being offered online. And if traveling to sites where we have instruction is proving problematic for the long term, the online courses from other programs or through materials could be beneficial to you. So where are these locations on site? The primary one for EP and our courses is at the Johns Hopkins Applied Physics Laboratory, which is located on Johns Hopkins Road just off Route 29. It's approximately 30 minutes from Baltimore, maybe about the same from Washington, D.C. So it's relatively easy to get there on major highways as long as you're not quite in the peak of rush hour. You can also take courses at the Homewood campus, which is in more or less the geographic center of Baltimore. And it can take a little bit longer to get through Baltimore City to the Homewood campus. Realize that the courses at the Applied Physics Laboratory are all offered in the evening, and that would work well with work schedules potentially, whereas most of the courses up at the Homewood campus are offered during the day. And certainly we have EP students participate in courses up at the Homewood campus during the day, but it means that you have to take a break in your workday, travel to campus, and sit in class, and then potentially go back to work after that. So if you're interested in nanotechnology, we do have the concentration. Beyond the 2 core classes that all material students have to take, there are 2 additional core classes, if you will, related to the nanotechnology concentration, and those are Introduction to Nanotechnology and Nanomaterials. In the springtime, for the first time, Introduction to Nanotechnology will be offered online. And similarly, Nanomaterials, I believe, will be bringing online in fall of 2018, potentially spring of 2019. So if you have an interest in nanotechnology and working on materials related issues that occur at the nanoscale, which is where a majority of electronics is being constructed these days, this concentration can be useful, and moving it into an online modality make it a bit easier to complete your coursework if that's something that you're looking for. So in nanotechnologies, continuing on, you would have your 2 required core classes, Structure and Properties of Materials, Thermodynamics and Kinetics of Materials. You'd have the required nanotechnology courses, namely Introduction to Nanotechnology as well as Nanomaterials. And then you would choose 6 additional materials related courses that are either offered through EP or through the full-time program at Homewood, and these can be online, they can be in person, they can be kind of a mixture, a hybrid of those delivery modalities. But you'd look for 6 additional courses, and obviously you would look for courses that fed into your nanotechnology interest, and these courses won't necessarily be in materials, and you would look for them in other programs, either in EP or at the Homewood campus.
All right. Thank you again, Jim. Now we'd like to share some information to help you take this next step. Some of the most common questions that our admissions team gets from prospective students is, what is the tuition and what resources are available to help me pay? So here it is. Our tuition is currently $4,055 a course. Each of our courses are 3 credits each, so this is the total tuition cost for each 3-credit course. Because our tuition fluctuates every year due to inflation, we encourage students to budget $45,000 total for their degree. In addition to tuition, though, I would like to say that you are not paying any additional fees. So there's no technology fee that you have to pay on a semester basis. Our part-time students do not have to pay a student union fee. Applicants for this program, we do not charge an application fee. The only fee that our students regularly pay is a fee at the end of their study with us, known as a graduate fee. You do have a variety of financing options available to you, depending on your personal circumstance. I really encourage you to investigate and to take advantage of any education benefits that your employer may offer. We unfortunately do not have any scholarships available for our online and part-time graduate students, but there are other associations and organizations that do. For example, the National Consortium for Graduate Degrees for Minorities in Engineering, otherwise known as the National GEM Consortium, offers fellowship programs. Rules, requirements, and application instructions can all be found on GEM's website. Just you can Google GEM to find their website. The application deadline for its fellowship programs, I believe, is November the 13th. So if you are interested in kind of taking advantage or applying to one of these programs, do visit their website and submit your application materials as soon as possible. If you are a U.S. citizen or a qualifying U.S. resident, you may be eligible to use financial aid. The financial aid that's available for graduate students is largely unsubsidized loans. So similar to that, you can, of course, finance your education through a personal loan. And if you are active or retired military and you have veterans benefits, you can, of course, utilize these to finance your education. We do have a number of active duty and retired military enrolled in our online and part-time programs. If you are planning on using veterans benefits to finance your education, here are some things to keep in mind. The URL that you see here on your screen, ep.jhu.edu/veterans, has a lot of great information on what forms you need to complete and submit to utilize veterans benefits at Johns Hopkins. The certifying official that's associated with the Whiting School, her name is Nancy Carr, and you can find her contact information by visiting this URL. She's incredibly helpful and responsive. She's great. For students who are using Chapter 33 post 9/11 benefits, please note that the Department of Veterans Affairs sets an annual cap on tuition for private schools. That cap is $21,970.46. So this is for an entire academic school year. It includes the fall, spring, and summer semester, and it renews every fall. So 5 courses will come in underneath that tuition cap. The cost for 5 courses is $20,275. 6 courses will exceed that tuition cap. So if you take 2 courses every semester for all 3 semesters in a year, 6 courses, the cost for that will be $24,330. Johns Hopkins is a yellow ribbon school. How yellow ribbon works at Johns Hopkins is that it's applied once the tuition cap is exceeded. And if it is exceeded, qualifying students can receive $1,000 per year. It's awarded on a first come, first served basis. The Harry W. Colmery Veterans Educational Assistance Act of 2017, otherwise known as the Forever GI Bill, was signed into law. This law expands on the veterans education benefits offered through the Chapter 33 post 9/11 GI Bill. For example, it removes the benefit expiration date for those who are discharged or released from the military on or after January 1st, of 2013. So if this is you, you now have an unlimited amount of time to utilize your veterans education benefits. They do not expire. For more information on the Forever GI Bill, I encourage you to visit military.com and search Forever GI Bill. There's some great information on that site. They have a lot of articles just talking about the different benefits built into that particular bill. If you are located outside of the U.S. and are interested in studying with us, here are some helpful tips to keep in mind. International students do have some additional admissions requirements. First, they must submit an international credit evaluation of any credit earned at any non-U.S. institutions. We prefer that they use the third-party agency WES for that credit evaluation. The credit evaluation product that you want to request is the ICAP. International students must also submit proof of English proficiency via, for example, qualifying scores on a TOEFL exam. On-site students, in order to maintain their F1 visa status, students must enroll full-time and provide proof of financial support to cover annual living and education expenses. Next steps and important dates. If you are interested in enrolling with us, if you're interested in this program, the first step is to, of course, submit your application for admissions. You can do this by visiting the URL that you see on your screen, ep.jhu.edu/apply. After that, your next step is to submit your academic transcripts and your professional resume. We do have rolling admissions for our part-time programs here at Johns Hopkins. It typically takes 4 to 6 weeks from the time that an applicant will submit all of their documentation for our admissions department and for the academic departments to review their materials and then issue that applicant a decision letter. So with that in mind, here are some important dates. Our spring registration will actually open on October the 26th. And the spring semester begins for us on January the 29th. So if you are interested in enrolling in our spring semester, I encourage you to submit your application as soon as possible, ideally well before December 15th. So that is the end of the prepared portion of this presentation. Now we'd like to open it up to all of you to answer any of your questions. Why don't I start off our discussion by kind of asking you, could you maybe describe a little bit about what classes are like with us within this program? Like how, in addition to class time, how much time outside of class is really expected to work on assignments and for homework?
Yes, well, clearly, you know, that varies by instructor, certainly.
Okay.
Yeah, the classes, especially the core classes, would meet once a week on a Tuesday or Thursday generally. In the evening, there are 2 slots in the evening that are generally available. And I think it's like 4 to 7 and then 7 to 10 or something like that. And our instructors generally choose the later time slot because it fits better with their work days, because our instructors either are full-time employees at Johns Hopkins Applied Physics Laboratory or are in industrial situations, and so their work days match up with our students' work days, and so in the evening is when they prefer to teach. So you would meet with the instructor during that meeting period. But then, you know, in terms of homework outside of class, generally you'd be looking at what would be a standard load where you would have maybe 6 to 8 hours outside of class meeting time when you would be expected to be reviewing notes or reading the textbook or working on homework assignments. And that's a rule of thumb. Now, in some courses, it would be lighter than that. I think that you would never get in deeper than that kind of time commitment outside of the class meeting period.
Tell our attendees, talk about the faculty within the program, maybe some of the projects that they or research they're engaged in, either here at Hopkins or otherwise?
Yeah, so we have instructors from a lot of different backgrounds. Some of them are chemists by training, some of them are mechanical engineers or physicists, and some of them are actually material scientists. And so they bring different perspectives to the types of problems they work on. But generally, it's all within the materials paradigm, if you will, structure, properties, relationships, and processing, and things like that. So one of our instructors who's from the Applied Physics Laboratory actually runs the additive manufacturing facility at JHU APL and does research in areas related to additive manufacturing, and is currently offering a course in additive manufacturing within EP. And we're actually building out that processing area so that we not only have the course he's currently teaching, but several other courses that will help introduce students to areas of materials processing, because the bottom line is you might know what you need to make, but unless you can figure out how to make it, you're going to be in trouble. So we're really building out the processing part of materials within EP. And I have to say that I think our full-time students at Homewood will end up taking courses in EP, because processing is not well represented at the Homewood campus in the full-time program. So that's John Slotwinski, Dr. Slotwinski, who does additive manufacturing. Dr. Farrar Gaines, or Danielle, she teaches the kinetics and phase transformations class, and she does a lot of research related to soft piezoelectric materials. So piezoelectrics are one of these fundamental enabling materials that shows up in your smartphone and all kinds of areas that you don't know they're there, and a workhorse of electricity and mechanical deformation. And you have piezoelectric materials in all timekeeping devices, actually. But when you start talking about making ones that are soft and flexible, and that you might want to maybe implant in somebody's body, or at least build it into clothing, there are very few options out there. And so her research is trying to develop a whole new class of these piezoelectric materials that would go into new applications that aren't possible right now. And one last person that I'd like to mention is Dr. Jennifer Samples. Jennifer is at the Applied Physics Laboratory as well, and she's a chemist by training, and she teaches our nanotechnology courses. And her research has been in areas in the past related to carbon nanotube fabrication and building devices using carbon nanotubes, including enhancing thermal transfer between surfaces by using carbon nanotubes grown on these two surfaces. And they actually use some of those materials in some space tests that they did, where they sent up this new way of making thermal coupling between electronic components. They built the interface and they sent it up for testing in space, and it was pretty successful. So that's Jennifer Sample. And I could go on and on with other instructors, but I'll stop right there.
Oh, wonderful. Thank you. Thank you so very much.